So can everyone hear me okay? Am I loud enough? I probably should have checked my mic volumes just in case. Okay, so it looks like we're good to go. So today I have some just general test taking tips. A lot of you should be taking the OGT next week or the week after. Kind of depends on your school district though, so that's just most everyone, but not necessarily everyone. If you're not sure of your OGT date, talk to Amy Wright. She is the one who has all that information. So some general test taking tips, and then there were some formulas on the reference sheet that we hadn't seen or used yet, so I wanted to go through some of those formulas. So when you're taking any math test and any test at all, it's very important to read carefully. It's super easy to miss information if you're not paying close enough attention. And it always helps to underline the important information, especially since most of these are word problems. We need to identify what's the information that will actually help us. Second, if you feel like you might run out of time, this test is pretty generous in their time. They give you 2.5 hours. But if you're going to feel like you're running out of time, do the problems you're confident on first. Get all the points you possibly can. Don't waste time on problems that you're not sure about unless you have the extra time at the end. But if you're skipping around, just be very, very careful that you're marking everything correctly. You know, if you skip a problem, don't mark your answer choice in the wrong spot. If possible, you want to answer every question, even the free response, even if you're not sure. Do your best. You never know when maybe you'll happen to get a point. So if you leave something blank, you know you're not going to get that point. So answer them all. For the multiple choice, eliminate any answers that you are confident are not correct. Using that process of elimination gives you a better chance. You know, if you only have 2 answer choices to choose from, you have a better choice of getting it than if you have all 4. If you do finish in enough time, always a good idea to go back and check your answers. Double check that you feel like you did everything correct. But if you run out of time, so let's say you've done all you can, but they say you only have like 3 minutes left and you still have 5 or 10 multiple choice answers that you haven't selected, select all the same letter. Pick all A or all B or all C. And again, this is a last resort because you're guessing on these. You're literally not putting any effort. But by selecting the same letter, you're likely to get a few of them correct. Whereas if you jump around and pick different letters, you have no guarantee of getting any of them correct. And then the last one, make sure you have answered the question on the free response. On those free response questions, identify what are they actually asking me, and make sure you've put that in a sentence. You know, the solution to this is 5. Make sure it's very clear you know what the answer is. If you have any other questions about strategies or concerns, feel free to send me a message and we can talk about it. But these are just some general guidelines that can help out. So some of the formulas we haven't used yet. We had a class session where we did areas, and we had a class session where we did volumes. But we didn't see any of the circle formulas yet, and we haven't seen all of the volume formulas. We did one with cones and cylinders. We've done rectangular prisms, which is the fancy word for box. That's also good to remember. But we haven't done right prisms or spheres or pyramids, so we're going to have a couple of area and volume problems to get to some of the formulas we haven't seen. So circumference of a circle. Circumference is kind of like the perimeter of a circle. Most of the time when we talk about perimeter, we're talking about shapes that are used using straight lines, and you just add them together to find the perimeter. On a circle, we don't have that option. We can't just add the stuff together, but we may still want to know what's the distance around the outside of this circle. If you put a string to measure around the circle and then laid it out flat, what would the distance be? So this says the largest pizza ever made in the United States measured approximately 140 feet across. What was the circumference of the pizza to the nearest foot? So the formula for circumference is on this reference sheet with a C. C here stands for the word circumference. And it's listed under circle. So we look for circle, we look for C. So the circumference formula is 2 times pi times radius. They don't put the multiply signs there. We have to know this is 2 multiplied by pi multiplied by the radius. So the number 2, that's normal. Pi, they tell you can use 3.14. But then radius, we have to actually fill in. We need to know what number is the radius. So on a circle, the radius is halfway across the circle. Since they gave us the 140 all the way across, we have to do something to that to get the radius. So what do we do to the 140 to get the radius if the radius is only halfway across the circle? Good. Divide by 2. 140 divided by 2 gives us 70. So now we can plug that in for the letter R. R standing for radius, just like C stands for circumference. And then we just plug it into a calculator. Let me pull up Google Calculator. 2 times 3.14 times 70. 439.6. And it says to round to the nearest foot. Sometimes, though, we don't even need to bother really thinking about the rounding. There's only one answer anywhere close to that. So what's our correct answer? The 440. Answer choice A. Good. If they were kind of mean and they put 439 or 440, we always, if it says nearest foot, that's the digit right before the decimal. It's to the nearest whole number. And then you look at the 6 and say, is that going to stay a 9 or is it going to round up? It rounds up. Since it's a 9, that rounds the whole thing up. It kind of has a cascade effect. It's going to make the 3 round up to 4. Because really you can think of it as 39s going up to 40. So they can also ask you the area of a circle. C stood for circumference, A stands for area. So the area formula is pi times radius squared. And again, this reference sheet, you have access to the entire test. You can just go look this up. You don't need to memorize it. You do need to know the A stands for area. So we need the radius on this shape. It says to calculate the area of the outer ring of the dartboard shown. So outer ring, that's this outside circle. And we want the radius, but they didn't give us the radius. They gave us pieces. So what do we do with those pieces to find the entire radius? Or what is the radius of this shape? Not seeing any answers yet, so let's discuss it a little further. So anytime you have pieces of something, you have parts of something, it's kind of like when you have money. Let's say you have a $5 bill, a $10 bill, and a $20 bill. Those are all pieces. This is part of your total amount. And you just find the total amount by adding them all together. 5 plus 10 plus 20 gives you $35 total. So anytime you have pieces in geometry where they're all on the same line, but it's been cut into individual pieces, each that are too long, we just add them together to find the total length of that line. Good. So that would be 6. So the line they have drawn here does go from the center to the outside. It's only halfway across the circle. So this is the number we need. We want this radius, and we just plug it in. Again, since the reference sheet says to use 3.14, we're going to use 3.14 4 pi times the radius squared. That's 6 squared. Now, in the calculator, you can do this a couple ways. 6 squared means to do 6 times 6. So you could always do 3.14 times 6 times 6. If you want to do the squared, there is a squared button, or there's this little triangle button. I don't have the calculator up today, so I can't actually show you on the calculator itself. But this little triangle button, we call it the caret key. The caret key gives the next number after it as an exponent. So that's 6 raised to the second. Or if you're worried about doing your exponent wrong with the calculator, just use multiply instead. So 113.04. And I stole this problem off the internet. It looks like they rounded a little bit incorrectly if you're using the 3.14, but there's only one answer that's anywhere close. And then the word square inches. Square inches just implies you're looking at the area. The inside of the shape is considered to be measured in square inches. So the circle formulas gave us circumference and area. We can also find volume of a sphere. So spherical objects look like balls, basketballs, baseballs, or the Earth itself is a sphere. So the radius of the Earth is 6,366 kilometers. km stands for kilometers. What is the volume of the Earth in cubic kilometers? Again, the cubic kilometers doesn't really matter. That's just to tell you we're doing a volume. So volume of the sphere, V standing for volume, is 4/3 times pi times radius cubed. So we only need to plug in our radius. What is the radius we should plug in? What number should we put in for r? The 6366. On this problem, they just told us what it was. So when you plug this into a calculator, we talked last time about using the ABC button for fractions. You can still do that. You could do 4, ABC button to make it a fraction, 3 times the 3.14, and then you can still use that caret key to get an exponent of 3. Let's say you don't remember all that. We know the fraction bar really means divide, so you can also type this in as 4 divided by 3 times 3.14, and then to the third power means we'd multiply by 6366 3 times. So either way you want to do it, at this point we plug it into a calculator. 4 divided by 3 times 3.14 times 6366. I did one too many. Let me fix that. Times 6366 times 6366. So this looks really, really funny. We got a super, super big number, and the calculator actually will sometimes automatically switch that to scientific notation. So on this calculator, when it switches it to scientific notation, it says E plus 12. When we have scientific notation, we normally write it as times 10 to an exponent. This calculator just represents it a little differently. That E means times 10 to the 12. And if we were to write that out longhand to the 12th power, that means we need to move this decimal 12 spaces to the right. So we have 1, 2, and then we just keep doing zeros. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the volume of the Earth is, let's see, thousands, millions, billions. It's a little over 1 trillion cubic kilometers. It's pretty big. So another volume is the volume of a pyramid. So the formula for a pyramid is kind of weird. On a pyramid, it says 1/3 times B times H, but it uses a big B. So the big B stands for the base area, or area of the base. When we have a pyramid, we can actually have a lot of different versions of a pyramid. You might have a triangular pyramid, and the base is the bottom. This bottom triangle would be the base of that pyramid. You could have a square pyramid. Sorry, these are a little hard to draw out. And you could even go up to weird shapes. You could have like a pentagon as the base of your pyramid. Most likely you'd have a triangular or square though. The ones with the weird shapes are harder to work with. So on the pyramid, the bottom is the base, and since you can have different shapes, they didn't actually just state the formula here. If it was a triangular base, then to find the area of that base, we go over to our reference sheet again and go to the area formulas. If the base is a triangle, the area of a triangle is 1/2 times base of the triangle times the height. Or if they give us a rectangular or square pyramid, the area of a rectangle is length times width. So this formula has to be a little bit flexible because you might have different bases. So this says a square house has a pyramid-shaped attic built under the roof, which you are converting into a spare bedroom. You're installing an air conditioner to cool the room. The perimeter of the base of the room is 190 feet, and the attic height is 6 feet. How many cubic feet of air are in the empty attic? So let me draw a bigger square pyramid. We know it's a square because they told us it was a square house, and then a pyramid-shaped attic, that's the top of the house. I'm only going to draw the pyramid itself. So on a pyramid, the height of the pyramid is actually inside the shape. If you go from the top to the inside, that's the height. And that's this part. And then we talked how the bottom is the base. And like many of the problems you're going to see on the OGT, they didn't just tell you the area of the base, they didn't tell you even the sides of the base, they told you the perimeter of the base. They said the perimeter of that square base is 190. So if all four sides are the same length, we know it's a square, so we know they're all the same. What number would we use? What number would make all those sides add up to 190? Or another way to think about it is we basically want to cut 190 into 4 equal pieces. So 190 divided by 4 is going to be that one, or the 40, well, sorry, I got to start that sentence again. 190 divided by 4 is going to be that 47.5 on each side. Good job, that is correct. So now that we know the sides, 0.5, now we can actually apply the volume formula. So volume formula said 1/3 times base times height. Since this is that square pyramid, we're using the length times width as the base area. So really we could write our formula as volume is 1/3 times length times width times height. So that base area is that length times width. So what number do we put in for length? What number do we put in for width? And what number do we put in for height? So 47.5, that will be used in for length and for width. We use it twice. Good job. What about the height? Okay, we have an answer of 9. Any other ideas for the height? An answer of 6. Okay. So the height, we just go back to the question. I probably should have underlined it originally. So they told us the perimeter is 190. They told us the height is 6. So be careful, and that's why I should have underlined it originally. They actually just straight up told us the height, but usually when there's a lot going on, we forget that information. So we should go back and underline it to make sure we know every important piece of information. Then we just plug this all into a calculator again. So 1 divided by 3 times 47.5 times 47.5 times the height of 6 is 4,512.5. And it doesn't say where to round, so we'll just keep it that exact answer. Another thing to keep in mind is if you use a value, we used that 190 for perimeter, then we probably aren't going to use it again. You can kind of cross it out and say, well, I used perimeter to find the side. I don't think I need that number anymore. This one I took from the math website CK12. It's actually a pretty good website if you wanted to check it out. They have lots of good lessons and example problems of just general math concepts. They don't address the OGT itself, but just a good resource. So on their day off, Candace and Trevor went to the aquarium. The Berryville Aquarium has a shark tank in the shape of a triangular prism. There is only one shark in the tank, so right now the tank is 2/3 full. How many cubic feet of water are in the tank? So important key things of this are that it's a triangular prism and that it's only 2/3 full. So we can find the volume of this prism but it would find the volume of the entire thing. So at the end, we're going to have to do something with that 2/3 to only get 2/3 of the volume. So a triangular prism is this right prism formula. And it's similar to a pyramid where the base really stands for the area of the base. So on this shape, the base is the top or bottom shape. They both are the same shape, so you can pick either the top or bottom depending on what they have labeled. So this is our base. What shape is our base in? It's a triangle. Good. We need to identify that because once we know it's a triangle, then we need the area formula for a triangle. This formula is what we're going to use in the base area spot. I meant to point at that. So our volume starts as base area times height. And now we know the area of the base is 1/2 times little base times height again. So we have two heights. Let's specify what each height is. This height, since it had to do with the area of the base, is the height of the base. This height, since it was from the original volume formula, is the height of the pyramid. Sorry, prism. Since our last problem was a pyramid, I said that again, but I meant to say prism. Height of the prism. So looking at our shape, what's the actual number that's the height of the prism, of the entire three-dimensional shape? And this we have to identify from the picture. They did not tell us in the sentence. Good. The height will be this 100. It's that distance between the top and bottom base. So the height of the prism is 100. Now let's look at the triangle. What's the height of the triangular base? Good, 80. On a triangle, the height of the triangle is that line that hits at a 90-degree angle and goes from the base, which is the 120, to the vertex of the triangle. So once you identify all the numbers, we plug them in. 1/2 times base of the triangle is 120 times height of the base shape, which is height of the triangle, and then times height of the prism, so times 100. Once you've identified that all and plugged it in, this is the easy part. We just plug it into a calculator. 1/2, again, you have the ABC button option. You have the 1 divided by 2 option, or if you know that the decimal is 0.5, you could use 0.5. So someone has already found the answer of 480,000. Just to double check by plugging it in, 1 divided by 2 times 120 times 80 times 100 gives us that 480,000. Good. And just for practice, just because it's good to have a lot of topics at once, let's write this in scientific notation. Just a little review of scientific notation. Our scientific notation, you always want the decimal immediately after the first non-zero digit. If they had something written like this, 0.48 times 10 to the 6th. Even though it actually will technically give us the same number, it's not written the right way. You could immediately say, this is wrong, the decimal's in the wrong spot. So 4.8 times 10, and then we just count how many spaces. So this is times 10 to the 5th because it took 5 spaces to get the decimal where we wanted. So that covers most of the area and volume. I think we've now done at least one of every type, and sometimes it gets a little repetition because you use, like we used triangles today, doing our triangular prism. So all of those formulas we've used. We also have down here the distance formula. So the distance formula is used when you're on a coordinate plane. When you have an actual graph, you can use the distance formula to find length. And it's pretty small, so I'm going to rewrite it just so you can see the entire thing. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So this particular problem, again, it's kind of a multi-step problem. A lot of these OGT questions, there's more than one step. So triangle ABC lies in the coordinate plane. What is the perimeter of the triangle? So they asked for perimeter, not area. And they don't list any perimeter formulas because it's the same for every shape. Perimeter is add up the outside lengths. So that actually means we're going to have to do the distance formula multiple times. We want to find the distance between each set of lines. So let's pick B to C first. It doesn't actually really matter which ones we do first because we're going to have to do all 3 of them eventually. So B to C, B was 1, 3 and C was 2, -4. To use something like the distance formula, each coordinate is always x, y. Every coordinate, whatever is written, always goes letter x first, letter y second. Since we have 2 points, we want a way to tell what's the difference between each of these x's and y's. So we put the 1 and the 2 just to say this is the first point. x1, y1 is x value from the first point, y value from the first point. x2, y2 is the second point. X value of the second point, y value of the second point. So now we plug this into our distance formula. It says to start with x2 and then subtract x1. So what are we going to put in our parentheses? What actual numbers will go here now? Two. Good. So we start with 2. Both of you are correct. And then what do we subtract? It's the x value of the first point. Good. 1. So as you're working on a problem like this, you can always cross out as you go as well. I used the 2, I used the 1. That way, when you do the y values, you don't accidentally use them again. So now we do the y values. What do I plug in for y2? -4. Okay, so we do have to be careful. We want the y value of the second point. The 3 is going to be the y1. So that order is important. Make sure you do second point minus the first. So simplifying something like this can also be a challenge. Once you get it in, now how do we simplify it? So we have to follow the order of operations in order to simplify this. So the first letter P stands for parentheses. We want to do anything inside of any sets of parentheses. So we're going to do the 2 minus 1, which is 1, and the negative 4 minus 3, which is negative 7. If you don't like doing integers, if you don't like doing things like this, use a calculator. If you are ever unsure, do negative 4 minus 3. That way you get the correct number out. So we did parentheses. Next we do exponents. Exponents are the little numbers up above, and they mean multiply the number by itself. 1 times 1, or negative 7 times negative 7. So 1 times 1 is 1. What's our negative 7 times our negative 7? If we have a negative times a negative, what's going to happen? And what's our 7 times a 7? Okay. So we're working with a negative 7, but we're multiplying them together. Negative 7 multiplied by negative 7 is going to be a bigger number. Good. Positive 49, and we had one person say negative 49. So you also have to be careful with your signs. A negative times a negative makes a positive. The reason that this rule, sometimes we forget about it, is because that's different if we were adding. If you did negative 7 plus negative 7, you get negative 14. It stays negative. When you're multiplying, a negative times a negative comes out positive. So we've done our exponents. We need to do our addition. There was no multiplication or division, so we skip that. We get square root of 50. So square root of 50 is going to give us, and then this you need to use a calculator. There's no way to do this by hand. I know approximately what the square root of 50 is, but not exactly. So 7.071. So now we have 2 more sides to find. This one is a time-consuming problem because it has multiple steps. We have from A to B, and we have from A to C. So when we do our next set of points, we need to redo what our first and second points are. They're not necessarily going to match up to any of the others we've done. So from A to B, this is our first, this is our second. And you may have picked B to A. Maybe you wrote B first, then A. That's fine. This could be our first point. This could be our second point. You just need to choose which one's first, which one's second. Then we find A to C. So A to C, this would be our first and this would be our second. Since we have 2 different distance formulas to do, instead of doing it all together, I'm going to have you guys do a problem. I think I maybe have a question, or maybe you just hit the wrong button. If you do have a question, you can just type it into the chat box and I'll answer. Someone hit the raise hand button and I don't know if they meant to or not. But while we see if someone has a question, I'm going to have you guys find the distance just to get some practice. So Kenya and Tasha, if you guys will find the distance from A to B, the one in pink. And then Crystal and whoever's on the iPhone, didn't put a name, which is fine. I want you guys to find A to C. If you're watching this video, I'm going to pause it, and you should pause your video and try them too. So we got the distance for A to B is 4.472, but A to C is a little bit harder. On A to C, there's so many negatives involved that it can really mess it up. So 7.07 is correct. We did get an answer of 7.07 now. Let me show you why that is. These negatives, like I said, really can be a big issue. So we have y2 minus y1. This is a -4, so -4 minus 1. And then on the x's, oops, I did that in the wrong order. I apologize. The -4 minus 1 should go here with the y's. When you do slope, y comes first, so sometimes I switch the order. But with the x's, you have x2 is 2 minus a -3. When you have this minus minus, that actually changes this to 2 plus 3. So 2 plus 3 is 5. -4 minus 1 is -5. And when you square each of these, both of them come out to positive 25. A positive times a positive makes positive 25, and a -5 times a -5 still makes positive 25. And then 25 plus 25 is 50. So we actually get the same distance again. We get the 7.071, which doesn't have to be the case. They just chose to make it the same distance. They could all three be different. So then again, we have to decide, did we answer the question? We found all the distances, but we go back to, they asked us to find the perimeter. If this were one of those free response questions, you would get points for what you've done. Finding all those distances gives you points. But then our final answer is to find the perimeter of the shape. So we add them all together. And it doesn't matter which order, just add all three together. And just use a calculator. This again is going to be too hard to do by hand. So 18.614, that should be correct. Good. So our final answer, using all the room for this problem, is 18.614. If they asked us to round, let's say to the nearest 10th, that's a common one to round to. That's one digit after the decimal, so you would have to decide, is it going to stay 18.6 or would it round up to 18.7? So what should we do? Is this going to stay a 6 or round up to an 18.7? Okay, we have one person saying 18.7. Do you guys agree or disagree? Okay. So to determine if you're rounding, so we have two 18.7, one 18.6. To determine on your rounding, you look at the number next to the 6. You don't consider the 6 itself. 18.6 is the correct option. The 6 would round stuff up, but we're actually looking at the 1 to decide. So if the number next to it is higher than 5, yep. So if this 1 were higher than, were 5 or higher, the 6 would round up. We don't actually look at the number itself. The 6, it doesn't matter where it's at. It's the 1 being less than 5 that keeps this 18.6. But I would have both versions written down, you know, write the perimeter you got, and then when it says to round, say, so this rounds to 18.6. Any other questions on this problem? It's a big, long, complicated one, so I just want to make sure before we move on. Okay, not seeing anything, so I think you guys are probably good. So another formula set we haven't talked about yet is this trigonometry. It's not going to be a whole lot of questions on the test. 1, I could see, maybe 2. There shouldn't be too many on trigonometry from what I've gathered. I'm basing this all off the ones they've released. So trigonometry is weird and different. It just is. It's kind of new. It only works for right triangles. And they're new formulas that they figured out for these right triangles. So each of these is considered to be its own formula. You can say it sin, cos, tan. That's how we abbreviate it. Technically, it's sine, cosine, and tangent. So I will probably say those words so you know what I'm talking about. Sine, cosine, and tangent. They just use sin, cos, tan. So it's comparing the angles on the inside of the shape to the sides on the outside of the shape. The angles are inside. These sides are all the outside lengths. So we need to look at this angle to help us determine what we should call these sides exactly. You'll see these words opposite, hypotenuse, adjacent, hypotenuse, opposite, adjacent. All of those words are the actual sides. Then the letter A, that's our angle. So the hypotenuse of any triangle is based off the location of this right angle. The hypotenuse is not touching the right angle. A to C hits that right angle. It touches the right angle. B to C hits the right angle. The only one not touching the right angle is A to B. They say that it's across from each other. So that means this side is called the hypotenuse. Opposite and adjacent is based off the angle marking here. So angle A, the side opposite, is kind of like hypotenuse. It's across. It's across from the angle. It's not going to touch the angle at all. So what side is across from angle A? Remember, when we say sides, we have 2 letters. We have AB, AC, or BC. One of these is across from angle A. Good. B to C or C to B, it doesn't actually matter which order you write the letters in. So this is your opposite side. So adjacent is the last one. Adjacent means next to. It's the side touching your angle, but not the hypotenuse. You should always identify hypotenuse first, because 2 sides are actually touching this angle. So adjacent is the one that's not the hypotenuse, that's touching the angle. So now they came up with these trig formulas. They said sine of angle A equals the opposite side over the hypotenuse. Or the cosine of angle A is adjacent over hypotenuse. And I'm going to abbreviate adjacent and hypotenuse. It's just long words to write out. And they said tangent of angle A is opposite over adjacent. And so they'll actually give you some numbers to fill in. These are the generic formulas. We haven't actually done a problem because we needed to talk about where these came from first. So they'll give you an actual right triangle with actual numbers on it, or variables. Our variable x is going to be involved in our formula as well. So the question says, what is the correct trig ratio for the right triangle? They want us to just write the formula down. They didn't even ask us to solve it, they just want us to write it down. So the angle is over here inside the shape. If you want to label it angle A, you can, or just knowing that the 23 is here, that's our actual angle. So we can actually eliminate one of our answers already because the angle should come immediately after the word sine, cosine, or tangent. So the number after sine, cosine, or tangent should be 23, and one of the answers doesn't say that. So which answer can we get rid of because it has the wrong angle? Good. Answer choice C. We're looking for this number here. It should have been a 23. We know that is incorrect. We're using that elimination process to get rid of that answer, makes our chances of getting the correct answer more likely. So then we have to identify hypotenuse, opposite, and adjacent. Always start with hypotenuse. So hypotenuse is the side across from the right angle. So here's our right angle. What number or letter is across from the right angle? 12. 12 is our hypotenuse. Okay. Next, we do opposite. Opposite is across from the angle. What's across from 23 degrees? What side is marked across from the 23? Good. Answer choice, or I saw the answer of X. This is opposite. Which leaves the last side to be adjacent. So adjacent doesn't have anything on it. It's blank. The blank one doesn't matter. The blank one doesn't help us. So we only have the words opposite and the words hypotenuse. This is where our formula sheet comes into play. Is sine, cosine, or tangent, which one of these only has the words opposite and hypotenuse? Good. Sine or sin, doesn't matter, means the same thing. So our formula is the sine formula. We can eliminate one more answer. Now we know it's not answer choice D. D said cosine. So the only difference between A and B is whether we put 12 over X or X over 12. Okay. So I have one person saying answer choice B. Let's look at the formula and decide for sure. Sine says do opposite for the top line, hypotenuse for the bottom. Let me say the answer choice first, and then I'll go back. Opposite is the letter X, so X should be on top and 12 should be on bottom. So we have one person that doesn't get it. Makes sense. Like I said, this is a weird concept. Can you be a little more specific? What exactly do you feel you're not getting? I don't know where to start the explanation over. Okay. So I am going to explain again. If you feel, because we're almost out of time, if you feel like you did understand it, you're welcome to leave now. If you want to listen to the explanation again, you're welcome to stay. When I do the explanation again, after that, I'm going to be done for today. We have our time is up. I am doing at least a session on Monday, and then I'm probably going to send out a survey. I don't know when everyone's taking their OGTs, so I don't know if we need a second session next week or not. So I'll send out a survey and see if we do want 2 sessions next week or just 1. So basically the trigonometry, oh, you take yours Monday, morning or afternoon? Oh, so this will be our last one for you. I don't work on the weekends, so unfortunately, we couldn't do another one. But there's lots of videos online, or you have the practice OGTs. It'd be a good idea to still practice on your own. So maybe I'll just do a survey to see if we even need one on Monday, because like I said, I don't know when everyone's taking it. So good to know. Thanks for letting me know. Good. Okay, I'll send out a survey and see then. Looks like most of you might not need it. Okay, so let's do an explanation of this again. You're so welcome. I'm glad I can help out, and I hope you guys do good next week. On our trigonometry, there's these 3 really weird formulas. The formulas, I'm going to try and be a little more simple. We need these formulas, and we need to just fill these formulas in with the numbers they want you to. So you don't need to have these formulas memorized. We just need to know that to fill in the formulas, we have to fill in the angle, and we have to fill in the specific sides. All of these opposite and hypotenuse stuff, those are the sides. And that's all they're going to probably ask you to do. They probably won't even have you solve it. They'll just have you fill in these formulas. And we need to know these formulas only work for right triangles. I'm going to actually go to a blank page. And put another right triangle in. Sorry. So to fill in these formulas, what you're going to have to do is identify on your triangle all 3 sides. Each side is the outside length of the triangle. And they will also give you a right angle somewhere, and they'll give you an angle inside the shape somewhere. We need that angle inside the shape in order to identify those sides. So these formulas can actually be used. The purpose of them is to find the length of the sides. If you only knew one side, you could find the other side length. But we just want to be able to plug it in. So for any of these formulas, the 15 always would go in the angle spot because it's inside the triangle. It's the angle they gave us. They have to give you that information. Okay. So when you're identifying the sides, which I have the green, the blue, the red, start by identifying the hypotenuse, which we determine from the right angle. Which color is going to be the hypotenuse? The green, the blue, or the red? Which one is across from the right angle? The red. Good. Very good. The red is the hypotenuse. Yeah. Then, and this is why I had to put the angle in, even though I haven't labeled any of the sides, I had to put the angle in because we identify the opposite and adjacent based off wherever they put that angle. So the angle is that 15 degrees. It's that space inside the triangle. What is across from the 15, the green or the blue? So which one is opposite the 15? Which one is across? It should be the side not touching the 15. It's going to be the side nowhere near the 15 if it's across. Oh, maybe it's showing a different color on your screen. I see light blue, so I think you mean this side. This was my green. This was my blue. I don't know if the colors were just, I don't know if it shows differently on your screen than what I'm seeing. To me, they look green and blue. Might look a little different. Okay, so for some of you, it looks light blue and blue. Okay, so the light blue is the correct opposite, or the green. It's opposite because it's not anywhere near the 15. The 15 is touching this darker blue line. It actually touches the side or touches the hypotenuse. So those are not across, those are adjacent. So that leaves blue to be adjacent. Okay. So in the end, you may not understand what the trig formulas really do. My goal is just to get it so you can actually use it and plug it in, even if you don't quite understand. It usually takes a couple of times of hearing about them to finally kind of get a grasp on, well, what does this all really mean? So I just want us to be able to use it by the end of our discussion. So if we were now given some more information, let's label the sides with actual numbers. Say this is 5, and this is 12, and this is 13. Now that we have actual numbers, we can complete our formulas for each of these. Since I gave all 3 sides, we can use any of these trig functions. So sine states it should be opposite side over hypotenuse. So what number do we put for the top of our fraction for sine? What's the opposite? Good. The 5 is the top. So then what do we put for the bottom? It claims it should be hypotenuse on the bottom. So what number is the bottom? Good, 13. I could do the same thing for cosine. It says adjacent over hypotenuse. So what number is, and it kind of is getting good, the 12. It's going to try and move it so it's not smashed with that formula. So 12 over the hypotenuse, which was 13. And tangent said opposite over adjacent. So the last tricky thing can be, well, what if they don't give you all 3 sides? Then we have to pick, do I use the sine, cosine, or tangent formula? So if they want you to find the correct formula for this, we have to decide, well, is it sine, cosine, or tangent? So we go through the process. So step 1, identify hypotenuse. Hypotenuse should always be first. And hypotenuse is across from the right angle. So which side, the 11, the x, or the blank side, which one's the hypotenuse? Okay, we have two answers, x or 11. So hypotenuse shouldn't touch the right angle. The bottom touches the right angle, the left touches the right angle. We want the side not touching the right angle. So that would be the x side. So that's our hypotenuse. Next, we want to identify the opposite. So opposite is determined by the angle they gave you. Again, opposite should not touch the 21. We want the side not touching the 21. We've identified hypotenuse, so now we only have 11 or the blank side. And you are correct, the blank side is the opposite. So that leaves 11 to be the adjacent. So third step is identify the adjacent. So now we need to identify the trig formula to use. Identify if it's sine, cosine, or tangent. If it's sin, cos, or tan. So the opposite side doesn't have any relevant information. It's the blank side. The blank side we don't use. We have to identify it, so we identify all the sides correctly, but we don't actually use it. So if we have adjacent and hypotenuse, we go over to our sine, cosine, and tangent formulas, and we pick which one. So which one uses adjacent and hypotenuse? I'm gonna write them a little bigger just to... Okay, sine and cosine both use hypotenuse. We had one answer saying sine and cosine. We have to pick one. We don't want it just to use the hypotenuse. We need it specifically to use adjacent and hypotenuse only. So let's, yeah, I was trying to write it bigger. Hopefully that maybe helps a little bit better. So let's decide then, is it sine or cosine specifically? They both have hypotenuse. Which one is adjacent only? Good, cosine. So our actual formula is cosine. Good job, guys. So then we have to actually fill in with numbers and letters. Actually, I'm gonna just write the whole formula bigger, and then it's easier to see. So our fifth step will be to plug in everything. We want to replace A with the angle, adjacent with the adjacent side, and hypotenuse with the hypotenuse side. So what number do we put in for A? Okay, so you wrote all of them. 21 equals, adjacent side is the 11, over the hypotenuse side is the variable x. So does that make more sense how to use it at least? You still might not understand exactly what it's for or where these formulas came from. Good, okay, but at least hopefully now you can use it on the exam. Like I said, it usually takes a lot of practice to finally get a grasp of what this one actually means. You're welcome, glad I could help out. We went a little bit longer today, but I wanted to make sure we got this answered. Thanks for joining me. I hope you guys do great on the OGTs next week. I'll send out the video link, and I hope, like I said, I hope you guys do great and good luck.